Hello, this is Mr. Stein. In this video, we're going to look at example number 2 from section 7.1, developing a system of linear equations. After you've done 7.1, you should be able to write linear equations from a situation, identify restrictions on variables. Remember the 3 steps that we're working through: define variables, identify restrictions, write the equations. We're also doing step number 5, verify possible solutions. Let's get to example number 2. Example number 2, create a linear system to model this situation. A school raised $140 by collecting 2,000 cans and glass bottles for recycling. The school received 5 cents for a can, 10 cents for a bottle. So, we're going to create our linear system. Step 1, define variables. So what is it that we don't know that we're trying to figure out? Well, we're trying to figure out how many cans there are and how many glass bottles there are. So I'm going to let C equal the number of cans, and then B equal the number of bottles. So we've defined our variables. Number 2. Now we're going to restrict our variables. Write down our variable restrictions. So, number of cans, it has to be positive, but it also can have decimals. So our number of cans, such that cans have to be some element of the whole numbers. So you have 0 cans, 1 can, 2 can, 3 cans, 4 cans, 5 cans, so on. Likewise, our bottles, we can't bring in partial bottles. We can't bring in decimals of bottles. We can't bring in negative bottles. We could bring in 0 bottles, but they have to be the whole numbers. Number 3, let's do our equations. Okay, so we want to identify the parts of the question where we can get our equations from. Okay, so there's 2,000 cans and glass bottles altogether. So it's a total. So we like that. Totals give us an equation. So the number of cans plus the number of bottles is equal to 2,000. That's equation number 1. Now let's look for our information for equation number 2. Well, we also had a total in dollars, a total amount. And then we have a cost of 5 cents for a can and 10 cents for a bottle. Now there's a little bit of a problem. We have different units here. We have dollars and cents. So everything needs to be in one or the other. So each can gets us 5 cents. So we get 5 cents per can. And we times that by how many cans we're going to bring in. Plus 10 cents per bottle, times it by how many bottles we bring in. And that will give us a total of $140. Now I shouldn't put the dollar sign in there. $140. So this is the total amount the cans bring in. And the second one is the total amount the bottles bring in. That's equation number 2. Okay. Now, in part B, the school collected 1,200 cans and 800 bottles. Use the linear system to verify these numbers. So this is step 5. Verify, right? We're not doing step 4 yet. We're doing step 4. The next 3 sections are all different ways to do step 4 to solve the system. But let's verify. 1,200 cans. So let's check this. 1,200 cans plus 800 bottles. Does that equal 2,000? And 1,200 plus 800 is 2,000. Does equal 2,000. So it's verified in the first equation. Now let's verify it in the second equation. So we do 0.05 cents per can times 1,200 cans plus 0.1 cents per bottle times 800 bottles. Does that equal $140? Now the first one was obvious. This one's a little more difficult. So we do 0.005 times 1,200, which is equal to 60, plus 0.01 times 800 is equal to 80. Does that equal 140? 60 plus 80 indeed is 140, does equal 140. So it has been verified in both equations. So you can see how this process works. We take our question, define our variables, identify our restrictions, write our equations, then we solve our equations, and then verify.